Hello everyone, welcome back to my YouTube channel. In this video, let us solve problems on three-phase induction motor for the subject name called Introduction to Electrical Engineering. So without wasting time, can see the numerical. A 208 volts, 10 HP, 4-pole, 60 Hz star connected induction motor has a full load slip of 5%. Find synchronous speed, rotor speed, and rotor frequency of motor. So first you should know the given values. They are given 208 volts line voltage, they are given, and they are given 10 HP, 4 pole, 60 hertz frequency. They are asking you to find slip. Yes. So that line voltage they are given, power they are given, frequency they are given, slip they are given in terms of percentage. You write in absolute value, that is 5 divided by 100. So synchronous speed is given by 120 F divided by P. We know the value of frequency and poles, that is 60 and 4. Substitute the value, will get 120 into 60 divided by 4, that is 1800 RPM. Similarly, to find the rotor speed or motor speed, N is given by Ns into 1 minus S. Ns just now calculated 1800 RPM. S we know 0.05. So we'll get rotor speed as 1710 RPM. The third one is rotor frequency of motor, that is Fr equals S into F. We know the value of S, that is 0.05. We know the value of frequency, that is 60 Hertz. We'll get 3 Hertz. So this is about this numerical. We'll go to the next one. A 6-pole induction motor is supplied by 10-pole alternator, which is driven at 600 RPM. If the induction motor is running at 970 RPM, determine slip. So here the alternator means induction three-phase synchronous generator, which is supplied to induction motor means generator which converts mechanical energy into electrical energy. That electrical energy is given to the motor that converts electrical into mechanical. So they're given the poles of induction motor and poles of alternator and speed of alternator. Frequency is the same for both induction motor and alternator, so that we need to find the frequency with the help of alternator parameters. Then we can find the slip. So that given number of poles of alternator, I'm noting that as a PA is 10 and speed of alternator, that is synchronous speed of alternator, that is NS or NSA or NA, that is 600 RPM. And number of poles of motor PM, they are given 6, and speed of induction motor N, they are given 970 RPM. So with the help of the parameters of alternator, calculate frequency. We know that frequency is given by Pn by 120, where we are calculating with the help of alternator parameter. Therefore, Pa into Na divided by 120. Alternator poles are 10 and speed of alternator is 600. We'll get frequency as 50 Hertz. Next, we can calculate slip. N you know, Ns we need to calculate, so that to find the value of slip, first you calculate synchronous speed of induction motor, that is given by 120 F divided by number of poles of motor, that is 120 into 50 pm is 6. We'll get 1000 rpm as a synchronous speed. Once after knowing the value of ns and n, we can calculate slip. S is given by ns minus n divided by ns, that is 0.03. If we want to write in terms of percentage, that is 3%. Similarly, the next problem. A 4-pole 50 cycles per second induction motor is running at 1445 rpm. Find slip, speed and slip. 50 cycles per second is nothing but frequency. They are given number of poles 4, frequency is 50 hertz, and they are given. We just have to calculate slip. Speed is nothing but the difference between rotating magnetic field speed and rotor speed, that is ns minus n. Then we can calculate slip, that is ns minus n divided by ns. So that ns first we should calculate, that is 120 f divided by p. We'll get 1500 rpm. Then you calculate slip speed, that is ns minus n. 1500 minus 1445 will get 55 rpm. Next, we can calculate slip ns minus n divided by ns. We can get 3.67%. A very simple and easy problem. Just have to substitute the values to the direct formula. In the last problem of this video, a 4-pole induction motor is connected to a 50 Hz supply. Full load rotor EMF makes 90 complete cycles in 1 minute. Find percent slip and rotor speed. 90 complete cycles in 1 minute means that is cycles per second you have to convert. That is nothing but rotor EMF, means that rotor frequency they are given. So that number of poles they are given, supply frequency they are given 50 Hz, and rotor EMF cycles in 1 minute they are given 90. So that you can get rotor frequency cycles per minute, that is 90 divided by 60. We will get 1.5 Hz. Next, slip is given FR, F, you can calculate slip with the help of FR equals S into F. So slip is FR divided by F, we'll get 3%. And rotor speed is nothing but N. If you want to calculate N, you should know the value of NS also. So you're calculating the NS 120F divided by P, that is 1500 RPM you're getting. Then N is given by NS minus NS into 1 minus S, we'll get 1455 RPM. So this is about three-phase induction motor. So if you're having any doubts regarding the numericals, feel free to write in the comment box. So if you really like this video, do subscribe and share maximum. Thank you. Have a nice day.